Architecture of the N5.2 reservoir. The root mean square amplitude, a seismic attribute generated over the seismic volume at different time slices, is more diagnostic in facies identification. Generally, the RMS amplitude is an expression of the square root of the average of the squares of the amplitude within certain window of the analysis, and it is related to the energy within the seismic trace. The root mean square, RMS, are useful in differentiating between lithology types. For instance, values of the trace with high amplitudes may indicate a highly porous lithology such as porous sand, which are potential high-quality hydrocarbon reservoirs. It can also serve as a direct hydrocarbon indicator. 3 different color bands are used to indicate amplitude values. Yellow indicates the highest amplitude, 100 RMS value, light brown to red, 50 to 68 RMS values, and the light green to blue colors represent the least to medium amplitude points, 0 to 18, and 20 to 30 RMS. The N5.2 sand falls within the beach barrier shoreface, BBS, RMS trend aligned parallel to paleo coastline direction, indicating a shallow marine depositional architecture. Depth structure map also indicated similar trends, showing a foray depth closure having 2 culminations and depositional axis parallel to the major structure building fault. RMS amplitude showing facies trends and architecture. Hint: BBS indicates beach, barrier and shore face architecture. The N5.2 sand falls within the BBS category. Depth structure map for N5.2 reservoir in 2 structural culminations and a saddle. Reservoir characteristics of the N5.2 sand. Well log attributes show that the N5.2 reservoir is a massive, clean and thick, about 70.08 meters thick, barrier/shore face shallow marine sandstone with excellent reservoir quality. Pixel-based facies modeling using sequential indicator simulation, SIS, algorithm for stochastic distribution of properties shows 3 distinct lithofacies, sand, siltstone and shale, in the reservoir across the field. These facies were defined based on log signatures, volume of shale cutoff, and net to gross, NTG, calculations. The volume of shale, VSH, net to gross ratio, NTG, and total porosity, PHIT, from petrophysical evaluation were populated into the 3D grid facies model, figures 7 and 8. Sand is the dominant lithofacies in the reservoir, with over 83% NTG and negligible volume of shale, VSH. This implies that the reservoir flow mechanism will be influenced by the properties of the sand facies. Facies model showing lithofacies characteristics of N5.2 sand. Porosity model for N5.2 sand.